Good evening. I'm John Toole, the Executive Director and CEO of the Computer History Museum. And I'm really pleased so many of you were able to make it this evening. It's really a sellout crowd for all of us in many different ways. How many people are here for the first time to the museum? Wow, that's a lot.
Wow.
How many people have actually either worked or seen or been inside the van? Big wow.
How'd y'all fit?
This is a loyal crowd, panelists. You're definitely a loyal crowd. But before we get started, may I ask that you turn your cell phones off, or your trios, or whatever you may be carrying? You know, you don't want to miss a moment. Well, only that Irwin Jacobs, you know, what can I say? I mean, gee. You don't want to miss anything this evening. But tonight you're going to hear an awful lot of things about history, the nature of change, and the internet, how fast things have changed and made a difference in our world. Really, the stories and artifacts really need to be preserved, particularly for all of us as this change accelerates. 500 years from now, 1,000 years from now, 50 years from now, 10 years from now, things are going to be quite different, and you're going to hear about that this evening. It's also an observation that as you learn about the internet history, you know, how controversial it is in places, you know, many people want to be called the first, or to call someone the father, the mother, the godmother, the godfather, or perhaps something even worse. Yet, despite who was first, or what really happened, no one can deny that there was this ugly-looking van in 1977 with people who put the excitement, passion, and technology really in front of everybody in the world, and demonstrated how a wireless world could operate across all kinds of networks in the future. Congratulations to you all on that one. This is actually a very interesting night for the Computer History Museum, and actually the same analogy applies to what we have been trying to do, discovering and exploring the past to preserve the lessons of history for tomorrow. Otherwise, they're going to be lost, and using it to create something very special and great, which we hope you will agree with us that we're really trying to do with your help and support. Tonight's event brings you the collaborative efforts not just of our own organization, but our partners, the Web History Center, SRI, and the people and companies that really have made technology so much part of our lives today. As CEO here at the museum, I'm truly proud of what we've accomplished at the museum over the past 2 decades, from Boston to NASA, to this wonderful building we purchased in 2002, to Len Shustek, who's chairman of our Board of Trustees, that have made all the difference in the world. We are becoming a significant Silicon Valley entity, and perhaps even more importantly, are really being known worldwide. And we're developing and saving computing for all of the world. We just rescued 7 large shipping containers, 7 large shipping containers. These are huge things, about half the size of a football field, from Germany, of a number of companies, of things that would have been lost and destroyed had we not been able to really get involved, and SAP was able to support that. We're unique in it as a collecting institution and are focused on the information age for software, hardware, networking, pictures, stories, videos, and documents, all related to our field. Many of our pioneers are still alive. As Len always says, and I've said, that's good, but it's hard, believe me, because you also want to vet those with those that are not with us anymore, because they contribute to history as well. And that's what a museum is all about. So it's an urgent and unique opportunity to collect the information, yet also to incorporate this knowledge from our colleagues all across history. You probably might guess that we are creating this museum in stages, just like networking has created networks in stages. In a few short years, we're going to unveil a 14,000 square foot timeline of computing history, and later theme rooms and rotating exhibit galleries with many new programs. I hope you'll take the public tours of a small group, which is really a small part of our collection, join our volunteer program that everyone can participate in, attend an incredible speaker program and programs such as you see here this evening, and enjoy major events such as our Fellow Awards that we just had a few weeks ago, and we now have 44 fellows beginning as our 20th anniversary. And I've got to say we're very proud tonight to have 2 of our fellows on stage, Vint and Bob. We're also building an exciting education program. We've just hired our Director of Education, but our main focus till 2009 will be, you guessed it, fundraising, and you guessed it, building our timeline exhibit. That is going to be spectacular and really set a stage both on the web and for the world what computing history can come alive. Our guest curator, Doran Swade, and the curatorial team of our staff and many other outstanding people are really helping to make this happen. And meanwhile, our collection continues to grow. We just purchased another off-site storage building to make room for our exhibits coming down up the road, and we continue to bring new stories and artifacts to the public through online access, restorations. We have a PDP-1 restoration working that you can come see, a 1401 that'll be very soon, and we've done a collaboration with Al Hoagland of the Disc Heritage Center on an original RAMAC disc. I hope many of you can join us on December 4th, another special evening where Doran Swade, our head curator, and Nathan Mervold, former CTO of Microsoft, scientist, collector, and entrepreneur. Doran is probably the world's greatest expert on Charles Babbage. And he led a project that actually made a Babbage engine in London. A second one was commissioned by Nathan, and also adding the printer, which was an integral part of the whole process. And that's about ready to be completed. So December 4th is going to be some background materials of what it was all like to build this machine. 5 tons and over 8,000 working parts. And then later on in the year, we are going to have that actual machine here in the Computer History Museum that all the public can see. We're just at the beginning, but tonight we are celebrating a wonderful event that has an incredible set of stories that you're going to hear, all part of the technologies we call the Internet. While the definitions sometimes change over time, I should say, the accomplishments by the people and the very real, extremely interesting stories have had an impact on us all. And tonight's presentation is really a joint effort between the museum and our partner, the Web History Center, this evening. For nearly a year, the Web History Center, SRI, and the CHM worked with many other organizations to make this celebration and reunion a reality. Don Nielson, Mark Weber, and Karen Tucker deserve a special thank you for all the work they put in and all the people that they got to work with them. And what a reunion this is tonight. We have over 18 of the original participants in the project here this evening. The one in 1977 represents 7 of the 8 institutions which have participated. And 7 of these pioneers have graciously agreed to be in our panel. And I'm very proud that we are all here this evening. Our sponsors this evening are particularly special to us, including 2 key participating companies in the 1977 milestone, Rockwell Collins and SRI, who did the packet radio portion of the experiment and are still leaders in that field today. But our lead sponsor that really made all this happen, and by all of our sponsors there, made that wonderful, wonderful reception happen, is Cisco Systems, the company that has really been able to turn many of the techniques pioneered in '77 into commercial reality, impacting all of our daily lives. I want to thank these 3 sponsors for making tonight happen and welcome them all tonight. Let's give them a big round of applause. And although the pioneers with us tonight have known each other, in 1977, guess what? This may be some of the first times in 30 years they've actually been coming together. And these returning pioneers are with us in the front rows. Would you please stand up and let us recognize those of you that actually worked on that project? Thank you for coming. Thank you very much. And of course, all the panel deserves the same applause. And finally, you probably noticed when you walked in that large vehicle at the entrance that looked kind of cruddy and it's kind of old, but that is the original van, okay? So if you haven't had a chance to tour it, and people like Don and his team of people have gone in there and outfitted it, just pretty much as it was, right, Don? and it's very well labeled, so you can take a tour after the event if you hadn't seen it originally. And I also want to say that, you know, the museum also has recognized its historic importance and really gave it a home a decade ago. We had it over at NASA Ames, and we brought it over here for this event, and we may definitely use it in the future for some other exhibition, along with many of the materials that document this important story, not just what you see tonight, but things in our back room, which is incredible. While tonight's public is a public celebration, the Museum and Web History Center are also using this reunion as a way to collect and gather some of our history from participants themselves. So we're doing a series, and Mark is doing a series of oral histories, which will help our future generations of what it was really like to be in that van and make history happen. Now I'd like you all to meet Mark Weber. Mark helped define what it means to be a web historian and has been researching its history since 1995, starting with pioneers at CERN in Geneva, Switzerland, where it all sort of started. Mark followed its trail to Silicon Valley, where he was naturally from, as well as back in time to its roots in hypertext and networking. And again, thank you all for coming this evening. On behalf of the museum, we're honored and thrilled to have you all here tonight. Let's welcome Mark to the podium.
Thank you, John. First, I want to thank Don Nielson of SRI, who was a key participant in the 1977 experiment we're celebrating, as you'll find out. But Don is the semi-official institutional memory of SRI, and he has written a beautiful book on their unique history. If every important institution had a person as a quarter as good as Don, we wouldn't be worried about saving the history of our digital era. When Don graciously agreed to serve on the advisory board of the Web History Center last December, he mentioned that there was an event he had been wanting to call attention to for many years and celebrate at the museum. I said that I thought it might be a perfect one to do as a joint CHM Web History Center effort, and the result is this anniversary event. And he is not only the instigator, but he has put in the hard work to make it happen, from inviting the pioneers to scrubbing down the step van and restoring its electronic guts, with help from some of his colleagues. Next, I want to thank our partner in this event, the Computer History Museum, and Karen Tucker, who has just left the museum to head the Churchill Club. She worked tirelessly to turn this event from concept to reality, and her creativity and contacts helped make it possible. I want to deeply thank John Toole and Shustek and all of the talented people here at the museum who have made this possible, as well as my colleagues at the Web History Center. And especially I want to thank our sponsors, with a particular note to the wonderful help we've received from SRI's Alice Resnick and Marty Maloney. You can read more about the center, the Web History Center, on webhistory.org. Our mission is to preserve and make public the history of the World Wide Web and also its roots in hypermedia and networking. Our motto is know the past, invent the future. And of course, I want to thank the pioneers for helping bring us the internet. And I now turn you over to the capable hands of our moderator, Gina Smith. She is a noted newspaper and television journalist, as well as the co-author of the best-selling I Was, the story of Steve Wozniak's life, and an earlier book on genomics for a popular audience which won a number of awards. Currently, she broadcasts The Week Ahead with Gina Smith every week at Infoworld.com and works as a freelance journalist for Computer World and Scientific American. So, thank you, Gina.
Hi, everybody. It is amazing to be here. I can't tell you how many times I've sat in that audience watching Walt Mossberg warm this chair for me. And it's really nice to have an opportunity to come address you, and an even more amazing opportunity to have a panel like this. A couple of you guys have been on panels, but I've never had all 7 of you here before. I want to thank the Computer History Museum for having me here, and John and Mark and Sylvia Paul for helping put this all together. They told me they wanted me to come and host this panel on, this is what they told me, the first major TCP internetwork demonstration. Now, I have been covering technology for 19 years precisely. I started 19 years ago at PC Week, and I have been at every anniversary that you can imagine. I was at the anniversary of the Trash 80, I was at the anniversary of VisiCalc, the Lotus anniversary, the Borland anniversary, I was at the anniversary of the IBM PC in 2001. You might remember that because David Bradley, who is one of the original 12 engineers behind the IBM PC, he's the guy responsible for Control-Alt-Delete, the 3-finger salute. He was on the panel, and he thanked Bill Gates for making him so famous. And there was a moment in time, you know, and I thought I'd seen it all. I had, and then I was invited to do this panel. I immediately Googled it. That's what we do. We Google things. We Wikipedia them. They're now verbs. Right? Are they verbs, Vince? Vince is the Google now. And there was nothing on the internet, virtually nothing, something very small that Vint wrote on the internet about this event. And that blew me away. Because if we're celebrating the 30th anniversary of something so apparently huge as to bring all of you here, a filled up crowd, why not more publicity? You know, and I asked Bob Kahn, I actually, Robert Kahn and I had an interview yesterday for a story I'm doing for Computer World, and I asked him, well, why not? And he said, Gina, you know, we were just building things. You know, it wasn't all about PR back then, right? And you didn't have Wagner Edstrom to come take all the pictures and put it online for you. After doing much research and reading one of Vint's papers, what he called this experiment was really, they were trying to solve what you called, the internet problem. Now, I have internet problems now, and they mostly involve spam and porn and my husband. But the internet problem he was talking about, it was the internet working of disparate networks. The ARPANET had already been up and running since 1969, so we're not talking about the ARPANET. We're talking about how do you connect the ARPANET to other disparate networks, and that's what this celebration is all about. They didn't know it on November 22nd, 1977. I was roller skating somewhere to the Bee Gees. But these guys didn't know it at that moment, but that night, data was flowing from a van here in Silicon Valley you saw the van, you were in the van, driving around. Data was flowing from that van to an SRI gateway in Menlo Park to a host at the University of Southern California, down in Southern California, via London. And it did this across 3 types of networks. It did it across the ARPANET, it did it across a satellite network, and it did it across packet radio, digital packet radio, which at the time was a huge, huge undertaking. And, you know, I want to open this panel quickly by saying this isn't my panel, although I'm loud and I'll get involved. And it's not really their panel, although they're very important and will all be in the history books. It's your panel. And we've got mics in the audience. And if you've got a question and you don't understand something and you want to get involved, please stand up. You wave your hand, I'll let you talk. And I've said the same thing to these guys. If you could have seen them in the green room, it was like a high school reunion of AV club people. I mean, they were hugging each other and saying, you haven't changed at all in 30 years. It was wonderful. It was wonderful. And I want to bring some of that to here. So we want to hear the technicalities of how this happened and how it affected the internet today and how it definitely affects Wi-Fi and all of those offshoots today. And we will do that as soon as I introduce the panelists. And I'm going to do it in the internet way, which is democratically in alphabetical order. From my left and going to the right, and I'm going to introduce them by their 1977 affiliations. This is Vint Cerf. He was at DARPA. This is Jim Garrett. He was at Collins Radio Company. Erwin Jacobs is next to him. He was at Linkabit, that's responsible for the satellite portion of this. Bob Kahn, another DARPA man. Whistles. Woo. Donald Nielson, SRI. Now you're going to have to whistle a lot for the shy one, Paul Spilling from Norway. He was with the Norwegian Defense Research Establishment. And Ginny Travers, a programmer with BBN. Thank you for that. We're going to open this with a presentation from Bob Kahn, one of the main architects of the ARPANET, a co-father certainly with Vint. A short talk by Vint, and then we're wide open for questions, and it can get as rowdy or as smooth as you guys want it to be. Bob, you're on. And he does a PowerPoint presentation against my advice. It'll be good, though.
Well, let me thank everybody here at the Computer History Museum. Is that on now? John, Mark, especially, you guys have these introductions down pat, so good show. My intent here is to set the stage for the rest of this discussion here. Clearly, we're celebrating a particular event in time that I think it's fair to say we did not know back then that there was any chance that 30 years from now we'd be picking that particular event to celebrate. It was merely a technological accomplishment that we noted. But it was not the first word in networking, certainly wasn't the last word in networking. And before I actually fully set the stage, I just wanted to give you some sense of what had come before. I noticed many of my friends in the audience. I see Ed Feigenbaum here. I see Doug Engelbart, Paul Barron in the back. I probably, you know, if I could just scrutinize the audience a little more carefully, I'd probably find lots more that I know really well from back then and subsequently. But you know, the world of networking really began with some of the early papers that Paul Barron wrote, Len Kleinrock wrote. J.C.R. Licklider, you know, articulated the notion of galactic networks. Donald Davies in the UK talked about packet switching back then. But it really was DARPA that put the field of networking on the map with the ARPANET. It was the first net, and it presaged everything else that came. In DARPA, there were two people that were responsible for getting it started. Bob Taylor, who was the director of the office when the program was first formulated, and Charlie Hertzfeld, who was the director. And they hired Larry Roberts to come in and run that program. Larry program managed the ARPANET. He really was the mastermind of the ARPANET project. As Gina mentioned, I had a role in that. I was sort of responsible for the system design. We actually built it, but there were so many people involved in creating all of that original networking that I just thought it was important to make it clear that this was not the first word, but that they all played a role, and many played a role subsequent to that, both in terms of institutions here, like the role that Park played. Certainly the Ethernet had a major role going forward. But at the time we did the demo, it involved 3 specific nets that DARPA had created. And I'm going to tell you a little bit about that and sort of how we came to be where we are. Some of the issues that we really have to deal with. Vint will carry on after me and talk a little bit about maybe some of the technology or some of his observations on it, but I thought that would be useful to actually set the stage. So the 3 networks that we were dealing with were the ARPANET, the packet radio net, and the packet satellite net. And our goal was to show that we could make them all work together. It was not just connecting the nets, but it was connecting computers on any one of those nets to machines that could be on any other net on any one of those systems. Those were all different. The ARPANET had 50 kilobit per second landlines. They took sort of larger messages and broke them into 1,000-bit packets, many host computers, and it really was the single thing that started the computer networking ball rolling. Packet Radio Net was created to demonstrate a new capability for using this technology in a mobile setting such as the military might encounter, but we also saw the commercial potential for this technology back then. It was omnidirectional broadcast. We had embedded computers. I think it might have very well been the very first distributed system that used embedded micros. And it also, interestingly enough, used spread spectrum, discrete sequence, direct sequence spread spectrum. Erwin, I kind of like to think of that as a forerunner of today's CDMA technologies, and I think it worked like a charm. I was particularly inspired by a paper that somebody had written called Poisson-Shannon and the Radio Amateur. It was written around 1959. I think it was Costas that wrote it, and really kind of laid out the benefits of going to a direct sequence thing. It was influential for me, but this was really the first network that demonstrated this kind of a capability. Packets were a little larger than the ARPANET packets, and you could do 100 kilobits in an urban environment with a lot of multipath, but if you kind of sighted the radios on mountaintops, so you got pretty good line of sight, we could do 400. We had delay spreads of anywhere from a microsecond or less up to 6 microseconds, and that's what gated the data rate that we could get. So this was not very sophisticated signaling, but it all worked. And then the packet satellite system was an attempt to get a linkage over to Europe. Part of the reason we did that was because we had been trying to build modem links to Europe on the ARPANET, and we ran into problems with the CCITT rules, which required all the carriers that were involved in providing any one of the links to all agree to any further extensions. It became politically impossible to continue it. That's what motivated us to do the packet satellite system. It's kind of like an Ethernet in the sky, if you will. That ran at 64 kilobits per second on the SPADE channels, which is what were provided at that time, and you could run 2 channels, the forward link and essentially the backward link, and get 128. The packets were even larger still. We were using the very large Earth stations that ComSat provided. They were like 96-foot dishes, if I recall, really huge. On Intelsat 4, 5 countries were eventually involved, but in the initial demonstration, we just used one of the ground stations in the U.S. and one of the ground stations in England. But eventually, Norway, Germany, and Italy were also involved. Norway is involved in this demonstration not by virtue of its packet satellite participation, but by virtue of its connection being the first connection on the international links to the ARPANET. And then from there, we went down to England to get back into the packet satellite net. So the ARPANET came first, and then basically the packet radio system, the packet satellite system, and even the internet developments that went in parallel with that sort of occurred almost overlapping in parallel. Now, I just would point out that the Ethernet development at Park was also taking place in parallel, but it was really not part of this demonstration. There were so many participants, I hesitate to even try and list them, so I'm going to do it by affiliation. On the ARPANET side, clearly ARPA was involved, BB&N, which built the nodes, UCLA, which did a lot of the testing. In fact, that's how I first met Vint, when we were doing testing of the ARPANET back in late 69 or early 70. And there were so many research sites that were involved, I really can't even begin to list them. On the packet radio side, again, it was ARPA. ARPA is a constant throughout all of this. Collins Radio, which built the radios. So these were actually digital radios. It had a little computer. It was, in fact, one of the first radios I know of that combined microcomputers in there. I think the Intel 4004 was on the market at the time. If you can imagine trying to build a radio with a 4-bit micro. I think just before we were ready to commence implementation, they introduced an 8-bit micro out of Intel. It was the 8008. And it looked for a long time like that's what we were going to use until just before we had to commit, National came out with the IMP16. That's what we actually used. An ugly machine to have to program. But, and I remember the folks from Collins really getting very upset because every time they programmed it would come up with a command like inferior exec, and they said, what does that mean?
What does it mean?
You ever figure that out, Jim?
No.
Yeah.
Okay.
No. Not a, it doesn't know.
It's an operating system thing.
Not a very friendly language.
Not a very friendly.
The packet satellite system started out in a very different way. It started out by trying to tag on some satellite code to an ARPANET IMP so that you could do memory transfers from one machine to the other and then up through a satellite. But eventually it became a standalone net of its own. Many people were involved there. ARPA, again, Linkabit was involved. Irwin was running Linkabit at the time. ComSat was involved, because you got to get to the ground stations. BB&N involved. Also UCL, University College London, NDRE, and UCLA. I kind of, different parties built different pieces of that system. But Irwin really was sort of the overall architect of what we actually did in that system, just as I played an architecture role in packet radio. On the packet radio side, BB&N built the first gateway as part of what was called a station because there wasn't enough power in the radios to actually do much other than take a packet in and put a packet out. And so the bottom line was that we needed a separate machine. It turned out to be a PDP-11 to actually do the processing, to figure out the routing and all that stuff. So they built that as part of the packet radio system. And of course, SRI was responsible for integrating, testing it, and actually making it real. And we tested it at a number of military test beds as well. Now, in addition to these three nets, Vint and I were working together on trying to figure out how you put it all together. And that's where the Internet protocols play in and the Internet architecture. ARPA was clearly involved in that through me and later when Vint joined, but also Stanford, UCL, and BB&N were involved in actually implementing the protocols. BB&N did both a TCP implementation and a gateway implementation. The others were more involved in the TCP side of it. So let me mention some of the issues here, and then we'll turn it over to Vint. And I'm going to focus on the issues that you may not know about, although some of them may have been apparent to some of you. First of all, in the ARPANET, we were all aware of the fact that we didn't understand exactly how to do routing. We knew how to make a route happen. We built a very generic system where you could plug in routing modules that could do different computations. And so the implementation was really generic except for these modules. We used shortest path first initially, and later it got improved. We knew congestion would be an issue. I knew that deadlocks in the net would be an issue. Vint and I've talked about this many times. With the Boston boxes where you have one car in an intersection blocked by another car, which is blocked by another car, which is blocked by another, and none of them can move unless they sort of all move simultaneously. Well, I knew that could happen, but I couldn't convince my colleagues at BB&N that this was an issue. And the argument was it's sort of like all the oxygen molecules in this room accumulating in the upper corner and everybody asphyxiating as a result. They said it would never happen. But Dave Walden and I went out to UCLA, and in fact, working on some testing with Vint later on, we actually demonstrated in 12 packets that we could lock up the whole net. When I went back to BB&N, the question to me was, well, how come we didn't know about this before? Bottom line is we did, so we went out and showed that it could happen. We talked with AT&T a lot about trying to get into this business, and AT&T frankly didn't see it as a business. And you know what? In the narrow aspects of the way businesses were run, they were probably right, because in 1972-3 timeframe, how many organizations were there that had computers that, large enough computers to talk on a net? Maybe 100. That's not a business to an organization like AT&T. So they were perfectly happy to sell the lines to the DoD and sit on the sidelines. And 10 years later, they discovered that it was something they really needed to jump in with 2 feet. Didn't succeed, but that's what they tried to do back then with a system called ACS. On the packet radio side, there were 2 issues I want to highlight. One had to do with the frequencies that we got. In the federal government, if you wanted to get frequencies for a government purpose, you went through something called the Interdepartmental Radio Advisory Committee. It's called IRAC.
That was your Iraq, wasn't it?
That was our Iraq.
That was your Iraq.
Yeah.
It was a hard place. And the way it worked is if you wanted to build something, you got an allocation. They'd say you could build it in this band, but then when you wanted to actually deploy it, they had to give you a specific assignment. So what we asked for was a 20 megahertz portion of some larger band. And I specifically asked them for a heavily loaded band, heavily occupied band, because I wanted to show that with this direct sequence spread spectrum, you could run underneath the existing signals without interference. So they said, well, we don't have any heavily loaded bands. I think they meant that they could offer. So I said, well, I'll take an unloaded one then. We don't have any unloaded ones either. So we said, all right, help us out then. I mean, this is a generic request. They finally came back and they authorized us to build the equipment. Collins Radio built it. These were test devices. We were trying to figure out what the delay spreads were and how the signals would propagate in the 1400 to 1500 megahertz band. And so Collins built the equipment. It wasn't cheap. It was multiple millions of dollars, but a year and a half later, we had it. We were ready to go, so I asked for an assignment. And they said, whoops, that's the band in which all of the en route air traffic control radars work, and in particular, San Francisco Airport was right. SRI was going to do the tests right there. So they said, we can't authorize you to do this, and so we complained bitterly. And behind the scenes, we worked a deal, and the deal was that they would let us do the tests, but not formally. We had walkie-talkies, so in case anything went wrong, we'd turn the system off at the drop of the hat. I don't know where Don was at the time. I think Stan Fralick might have been involved. There were a bunch of other people. I was up in Mount Tamalpais. I remember calling my dad.
In the snows of Tamalpais.
Yeah, I told him, where am I? I said, I'm in San Francisco, and we got 2 feet of snow on the ground. And he said, where are you? He says, they've never had 2 feet of snow on the ground in San Francisco. I said, no, seriously, I was up on Mount Tamalpais. So I was in the Air Force radar station looking at the Air Force radars, and people were at the regular en route air traffic control centers. We actually ran the tests, and we cranked the power up, and we were actually able to show where you could even first see it, where it didn't affect anything, but it was visible. And at that point, we just shut it down because it was visible. And when I got back, I kept this very nice letter from the FAA saying, we're outraged to hear that you ran this experiment without approval. But it was all prearranged, and that was one of the issues.
Yeah.
I got my wrist formally slapped. The packet satellite system was in many ways the most challenging because when we tried to set that up, there were no domestic satellites. And if you know the way Intelsat works, the footprint of the satellite was just allowed to carve out just enough of the East Coast so that there would be very little chance of any U.S. traffic using Intelsat. So there was no way we could do a domestic test there, and there were no domestic satellites. So I tried to get ComSat to provide access, and they basically rejected the request. They had a point-to-point tariff, so they would sell us lots of circuits. They had a broadcast tariff, but both of those tariffs were n-squared cost tariffs. If you added n stations, you had to have like n times n minus 1 over 2 direct links, or it was basically an n-squared problem, and I wanted a problem that was not a function of n at all, constant, because we're only using one channel. I figured, we ought to be able to put as many countries on this as possible. And they said the policies of Intelsat require that the charging not be a function of the number of countries. So the best we could ever hope for was a linear charging algorithm where every country paid the same amount. That's what we negotiated. It was called a multi-destination half-duplex tariff, where you could basically any country could join the satellite system, and they only paid for their uplink at the normal rate. But everybody then could communicate because it was like an Ethernet in the sky. Well, with ComSat being the direct interface to Intelsat, we couldn't really proceed. And ComSat told us in no uncertain terms that they would not countenance using anything but the existing tariffs, which were n-square tariffs. So I approached the DoD, and I got a friend of mine who was running the military satellite office to agree to give me a channel on the discus satellites, the defense communication satellites. It was kind of a rare commodity, and he really didn't want to do that, but he agreed to. Furthermore, I found out that there was an interesting thing written into the authorization legislation for ComSat. Even though they were the main interface to Intelsat, the DoD had a national security bypass. So they could go directly to Intelsat if they wanted. So I called George Lawler, who was then the marketing guy at ComSat, and I told him, thank you very much. I appreciate, what you've been doing, but we're going to use the defense satellites. And by the way, if I ever need to get to Intelsat, we'll just use this other bypass mechanism. Well, the next day I got a call back saying they had rediscussed it. Now they were willing to work with us. So that was a really interesting set of issues for me, anyway. The other one had to do with BBNN, because BBNN had built this. With funding from DARPA, had built a satellite IMP that was essentially treating the satellite as a modem. So the way you went from the ARPANET into the satellite code was through in-core memory transfers, and went over the satellite and back into the memory of an input at the other end, so there was no separate net that you could get your hands on. And I knew that in order to really do justice to this concept of internet networking, we needed to make that a separate net. And so I had to convince BB&N to pull that code apart and put it in two separate machines. This was probably the hardest single technical thing to achieve because they really didn't want to do it. And they had all the technical arguments on their side. That is, it was 3 boxes, the ARPANET IMP, the gateway in the middle, then the satellite IMP, versus 1 box that did it all together, that it was 3 times the delay to go through it, 3 things that could fail instead of 1, and they thought the logic of that technical thing would hold the day. The problem was we controlled the funding, and we wanted a clean interface so we could put a separate box called a gateway or router in between. Well, needless to say, we finally won, but only through a very complicated political arrangement, which had the division that Ginny Strasser back then was in, both building the gateways, and of course they were building the TCP protocols jointly with Vint, but another division that was building the original satellite IMPs and ARPANET IMPs doing the other things. So BB&N had a responsibility for all the pieces, but in 2 separate divisions, and I got the management of BB&N to agree to make that happen. So that was probably another one of the major issues that I think I flagged for you. And then finally, I want to say something about my collaboration with Vint. It really did start back in the ARPANET days, as I said, but I was really a person who grew up in the communications world, as did Erwin. In fact, Erwin and I were both faculty members at MIT back in the 60s. We had offices right next to each other. And my background was really in applied math and electrical engineering. And Vint was a computer scientist. He had participated in the early NCP development for the ARPANET, which in a nutshell sort of treated the ARPANET as kind of like a peripheral device, whereas I was trying to make the computers more like communications devices so they could deal with errors in the net and lost packets and the like. And I had asked Vint if he would be willing to collaborate with me on this. I had sort of a pretty good idea of what I wanted to do, and a lot of that's documented in that paper that Barry Leiner wrote, but I didn't have any idea about whether this design really would work well with operating systems. I didn't have any idea about how to get it in, and that's what Vint had spent quite a bit of his life doing. And between the two of us, we then took these ideas and made them a lot better. I mean, I think without the collaboration with Vint, this never would have happened. And we worked together very closely for many years thereafter. So after that collaboration, we were in a situation where these nets were not just put together for a 3-net demo. Clearly the notion of connecting the packet radio and the ARPANET was something that had to happen, one, because that was the only way we could actually get the protocols developed. But computers back then were really large. They took a room with air conditioning and the like, and you weren't going to take them around with you in a mobile environment. So if you were in a mobile van, your computer was probably going to be on the ARPANET. So we had to connect those two just to show how that would work. And the whole purpose of the satellite net was to get the connectivity over to Europe for a variety of reasons. So that had to happen. I am sure in the 75 to 77 timeframe, there were pairwise connectivity between ARPANET and satellite net, ARPANET and packet radio. It's been lost in antiquity as to exactly who did what, when, and where. Probably it was in a back room at BB&N. Conceivably it was done in a back room at SRI. And sort of that was the history. I also wanted to mention that we were also operating in the awareness of what the folks in Hawaii had done. Abramson and Kuo and Dick Bender, who's in the front row, had been involved in creating something called the Aloha Net, which wasn't quite a distributed network in the sense that a packet radio was. But there were so many things going on back then that I think we were just very fortunate to have been there at that time and place to have brought this all together. So I think that's about as far as I want to go by terms of setting the stage. But that was the context in which we were operating back then. And I think we're all delighted to be back here again and reconnect with old acquaintances. So thank you very much.
Thank you, Bob. Vint, you want to jump up?
thank you. That's, am I on? The standard question is, can you hear me back there in the rear? And the answer is no, we ain't built that way. It's November 22nd, 1977. It must be somewhere around Thanksgiving. Are we going to have a turkey, or are we going to have something to celebrate? I have to tell you that Bob's very complete description doesn't require much augmentation. I will say that by the 1977, we had been through several iterations of the TCP protocol design. It was not long after this particular test that we realized we needed to split off the IP layer of protocol and make it something that would carry things in real time but not necessarily deliver everything reliably. Danny Cohen is in the audience somewhere. Danny, wave your hand. There he is. Danny and John Postel and David Reed were all involved in persuading me, who was the program manager at the time, that we needed to do this so that we could handle things like packetized voice, radar tracking, and other stuff, where you really want to know where is the missile now, not where was it 5 minutes ago. So in any case, this test probably used just the TCP protocols to go through through Ginny's gateways. In many respects, this is Ginny's test, because the other networks were essentially operational by that time. They were functioning. You could demonstrate them very successfully, but we never actually got all three of them working all at the same time. And I felt very strongly as the program manager, having left Stanford and come to ARPA, and Bob went on to become the director of the office, the IPTO. I felt very strongly that it would be convincing to demonstrate that the technology we developed, which was supposed to show how multiple networks could be interconnected, would be more convincing if it could do 3 instead of 2 at a time. So this test was more or less put together by asking the various contractors to demonstrate this full-scale, at that time, full-scale capability with all 3 of the networks. Because the nets were more or less already running, it was Ginny's job was to get the software in the gateways to correctly work. And at some point, Ginny, I would like to know whether you had to jigger the routing in order to force the packets through all the various networks, because the natural path from San Francisco to Los Angeles would have been out of the packet radio net and straight down through the ARPANET to USC ISI, a 400-mile shot.
Can we ask for Vint? Was there any jiggering?
Jenny, did you have to modify the routing and force the traffic all the way through the packet to satellite net?
I don't remember, but
I'm almost certain that you had to do something.
I mean, there were definitely routing algorithms that would have sent things, in the shortest way possible.
Yeah.
And in fact, one of the problems in doing this demonstration is that network demonstrations are, they're like earth-shattering, right? I mean, it's like you'd have to sit there and say, yes, the packet really did go from here to here to here to here to here, and there was like little evidence of that.
Ginny, it's not out of the question that back in 1977, the network thought the shortest path was through London.
No, we were better than that. We were better than that.
So what was pretty dramatic, I think, is that when you look at the picture that's been out there, and I don't know if we could get it up on the screen here, but that the map of all 3 networks, if you calculate how far did the packet actually go, it was well over 88,000 miles, because it went through 2 satellite hops and came back the other way, even though the crow flies distance was only 400 miles one way. We learned a lot from the ARPANET work. One of the things we learned was layering. And we learned that segregating the networks from each other and minimizing the amount of interaction between the nets, even while they were interconnected, was really important. And that's why the gateway concept and Bob's notion of sort of a standard interface that would allow many networks to interact was so critical to the design. I have to admit, when Bob first explained to me about the packet radios, my first reactions were, boy, that makes a lot of sense. If you're in a militarized environment, you're mobile, you can't have wires dragged around behind the tanks, because the tanks run over the wires and it doesn't work very well. So radio seemed like it was very sensible. And then he said there was something about this spread rectum radio. And I remember thinking, what the hell is that? And I later understood that it wasn't pronounced that way. a very powerful, very effective, evocative kind of technology.
We get it.
The thing that made the packet radio net so unique is that its topology kept changing. Even though we had the repeaters up on the mountaintops, the devices that were moving around in the net were changing their connectivity all the time. It's one of the reasons that was such a terrific challenge. So when the day came to actually demonstrate this capability, I had several objectives in mind. One of them is hoping that it would actually work, because it would convince me, along with others, that we really had something that worked. And in fact, when it did finally work and it was successful, I remember hand drawing the picture that you see a better copy of out there, having it framed, and sending it up to George Heilmeyer, who was the director of ARPA at the time, to try to persuade him that the money that had been spent so far on this program was worth it, because the technology was showing that it could actually do what it promised to do. What I'm interested in hearing, though, is more about what actually happened that day and what kind of challenges had to be overcome. I wasn't physically present either at SRI or in London or in Norway. I think I was probably in Washington at the time. And it was really the contractors who made this thing happen. And if ever there was a group effort, this was it. People utterly committed to making this stuff work. And there are a lot of them right here in the audience. I've been sitting here looking out there, and I've got a list of at least 50 people here just from looking at you from the stage. It's an amazing collection of horsepower and history that's sitting in this room right now. And for some of us who are approaching, an aged number, it may be that we have collectively one brain cell that will be able to remember some of this history. So I'm hoping that the rest of the evening will evoke some memories from the people that are here and folks that are out in the audience. And especially Danny, I think you should bring up that special packet test that you did. So why don't we just turn this over to discussion about what happened that day and what problems were there and what came out of it.
Thank you, Vint. I really appreciate it. Vint makes a really nice segue here because Don Nielson this morning was telling me a very interesting story about the type of things he had to go through to even get this 3 network tests going, and they involve the CIA and all kinds of governments and military.
I don't know that it can be comprehensive, but the first thing I want to say is that Jim Garrett and I had the hardest job of any of them. Isn't that right?
Amen.
Why? The packet radio?
I mean, when you told some sort of communication engineer in that era that there was such a thing as a error-free digital mobile network, that was some sort of oxymoron.
Exactly.
And it was true that the communications of the day just was not oriented to the word, to how on earth one could compensate for the vagaries of that kind of an environment. I remember there's one other thing you need to be grateful for, and that is that we were the integrator, and so all those countless demonstrations that we had to put on sort of error-free, you should be eternally grateful for those, as those were just seemed like gangbusters.
That was just good judgment.
It was a good judgment. Thanks. Any rate, getting something like that van, a mobile environment where computers could really reasonably function in them, or access to computers could function, was a challenge, and it took us a while to figure out all the, it was kind of hard to say whether we should measure packet loss rate or packet success rate. But the protocols that were worked out, the cyclic redundancy checks, the spread spectrum that we tried to use, but somehow phase wasn't knowable, and so we had to retreat a bit from that. But it all came to pass, and it was an enjoyable collaborative experience for us. The demonstrations, I got to say one little word. Well, first of all, about a decade ago, I think I was on a panel similar to this, and there was a gentleman by the name of Brian Reed, who many of you know, was there, and we were talking about this demonstration, and I said, it went all these distances, and all you really saw was delay. And he says, so what's changed? I want to read an excerpt from of an email of that era, and I stumbled on this quite by accident. It was written by Ron Kunzelman, who I think was project leader of the effort at SRI at that time, or maybe he was just doing the demonstration.
Go ahead.
But it's really kind of funny, because this tells you in a nutshell one of the struggles we had but also one of the reasons why the van is a notable piece of equipment, even though it's just a plain old bread truck.
Don, where do you go to stumble on your email from 1977?
How long did they what?
Where do you go to stumble?
I was wondering the same thing.
Actually, I went through the contract files at SRI, and this is the only piece of intelligible thing I could find in there. Anyway, here's a little bit of it. It says, thanks again. He's thanking the people at SRI who put on the demonstration. I'm sure there were extensions of this at Collins and other places. But we just did demos 16, 17, 18, and tomorrow we'll do 19 and for the TCP working group. But he goes on to say, I think we really helped ARPA this week in their dealings with the Army Science Advisory Panel with DDR&E, which is a development group in high level in the DOD, several Army orgs, and so on. Vint Cerf says that, this quote, a packet radio van ride is a religious experience for all who take them. And he's pretty much right. Most skeptics seem to be converted after their ride. And he goes on to say it's near perfect timing because coming back on November 8th, this was written back in October of 77, we have a 2-star General Hillman who happened to be in charge of the Signal Corps and a 4-star general coming to ride in the van. That's pressure. At least we felt it. And so a little thing like a 3-network demonstration that we're celebrating was just another little glitch in the road between this royalty that we were trying to make a good representation of for ARPA. And it was in retrospect, it was a pleasure. In the meantime, it was, I think Ron had a name for it. It was DNR. It was Demonstration and Recovery instead of R&D. Anyway, we had a tough environment in the Packet Radio Network, but it was really Collins and SRI working on the receiver designs, on the alt routing, and how on earth you made up for the fact that packets could in no way be guaranteed to go from source to destination, that made it all possible. And now, of course, today's networks have a variety of different media which are transparently handled.
Don, could I interrupt with 2 observations about demonstrations and the like? My recollection is that General Starry, who was the general in, 5th Corps or something? Was
Training Command.
Thank you.
Training and Doctrine Command.
He was out for one of these rides, and my recollection is maybe wrong, but is that after this successful demonstration, he wanted to know if he could have 50 of them. And the problem is, they're $50,000 each, and they're experimental. And gosh, Rudy, we're not about ready to release those until we're done with all this demo work.
We were ready to sell a lot of them.
Well, you were ready to sell them, right? But the other thing is that I wasn't present for all the demos that the guys at SRI did. They did a bunch of them. But one thing I do remember is that I was the only guy who could sit in the room where the demos were going on and could tell if the packet radio was actually working. The reason is that I have hearing aids, and they picked up the signal. And it sounded like, crinkled paper, right? And when the crinkled papers stopped, I would kick one of the SRI guys under the table, and he'd go and repower the device. And make sure it was still working.
Jim, you've been
Is that what you call carrier sense?
That's right.
Yeah, I wanted to bring Jim in because I saw him shaking his head during something Robert Kahn said, and also he was telling me that DARPA was one of the hardest clients he'd ever dealt with. And
Yeah.
what's the challenge?
One of the most
there?
refreshing things as you get older and you become a pioneer is
Congratulations on
these
that.
are no longer my customers, so I can say what I think.
I'm ready. Here we go.
And Bob actually very, very much characterized from the radio manufacture and design of the packet radio, some of the challenges that we faced. He mentioned this direct rectum or spectrum. At the time, that was a major challenge for us, and particularly with the fact that they figured out, this packet switching, the way it really, as explained to me at the time, was that it had to be as high an instantaneous data rate as you could get because you're trying to get these computers to communicate with each other. And then, of course, they decided that they wanted to demonstrate this in downtown San Francisco with lots of multipath. And we did a lot of, as I think Bob mentioned, a lot of characterization of the channel, and SRI did a lot of the work doing that and figuring out what data rate, the maximum we could deal with from a terminal to a repeater was one of the key decisions. And then once we decided it was 100 kilobits, was how in the world are we going to recover that signal? And the direct sequence spread spectrum was the answer. And along with some, at the time, and you got to remember this is in the early 70s, as far as, you know, we all have these cellular telephones in our pocket, and all this seems simple based on a lot of the work that my gentleman sitting next to me has done. But at the time, there was a lot, that was a big deal. And
literally physically a big deal. If you go into the van, you'll see this cubic foot of radio gear and computing gear, which gets boiled down to a chip or two today.
And so that was a major challenge.
One chip, all of it.
Part
of one chip, even more.
Part of one
wow.
chip.
Part of one
wow.
Yeah, it really makes me feel insignificant. But at the time, it was a big deal. The other thing is that Bob mentioned was this use of this microprocessor, and that was really the first time Collins was a leader at the time in communications, and really was a leader in the area of computer communications, but not to the extent that DARPA challenged us. And the use of that M16, and as crude as that really was, to try to implement the protocols, because the packet radio had to operate both as a terminal and as a repeater, and all of the protocols that had to be developed. I might add that on a non-technical basis, one of the real challenges for a bunch of engineers from Dallas, Texas, that were challenged with developing this radio was the interaction with people like Vint and Bob and Leonard Kleinrock and Howard Frank and all the people that were the experts in protocol development. And it was really quite an interesting cultural clash to try to understand what they wanted and get that implemented into the radio.
Was it the California speak versus the Texans?
Well, Texas speak is always difficult, and BBN, of course, is in Boston, so there was always a lot of challenge there too. So those are some of the things that I recall about it. I have some other things I'd say, but I certainly don't want to monopolize this.
Do you happen to know whether any of maybe Don would remember, were any of the Collins guys at SRI at the time this particular test was done?
Mike Sisko was there.
Mike, you were there.
Sisko?
Okay,
Yeah.
great.
He was there.
And
he used to be dark-headed before that. So.
Oh, that's why I didn't think.
You all were, I think. No, I mean, this is when you look at this packet radio, it's hard for some of us to imagine. This is the first digital packet radio, and you know, everyone born after 1977 should just leave the room right now.
And mobile.
And money, exactly. And mobile, yeah, absolutely. I want to move on to Irwin to talk about some of the other challenges. Irwin, you may know, is chairman of Qualcomm these days. He's done well for himself. But in those days, Linkabit, satellite technology, lots of challenges there for 1977.
Yeah, actually, I remember one of the non-technical type of challenges. Bob and I took a trip over to Europe to try to talk with the various PTTs, Post Telephone Telegraph Companies, about becoming involved with this experiment with packet switching, getting an extension of the ARPANET over to Europe, making use of it. And what I most remember is that we were always welcomed in, that they served absolutely magnificent lunches, and then they threw us out. The idea of, first of all, going away from wire, of course, was not a particularly good one. And having packet switching rather than circuit switching was just, much too, why would we ever be interested in doing that? And no matter what we might say about it, there was no way to kind of convince them that this would be a good thing. And thinking back on that and now, where wires are becoming items you do put in museums, and I think very shortly the circuit switches will also be cluttering up museums, and so we're all going to packet switching. Now, in saying that, getting voice over packet switch, doing that efficiently, one of the other memories of the experiment that time was in fact running voice over packet switching through this pair of satellite links, through all this other switching, through very slow computers, through very slow links, none of which had been optimized for latency or for quality of service. And so you said something and then you waited. And several seconds later, you might get a reply back. And so the quality of that voice over internet protocol left a lot to be desired at the time of the voice over. It wasn't fully over internet protocol, but over packet switching.
Were there any big
Again, I think the PTTs, if they had been there that day, probably would have thought, yeah, they were absolutely correct. Of course, now that's where we're going. It's going to be strictly voice, packet switched, wireless. That's the name of the game.
You answered my question, but all of you were raising your hands. What did
Gina,
you say,
can I just make
Paul might say something.
one comment here about the PTTs?
Yeah.
Just to make Erwin's point, there was the
we
PTT.
can't hear. Can we just pot up Bob, please?
Can you hear it? Well, let's see.
Yeah, you
I'll
got to
try
talk
it
right
this
into
way.
that, baby.
That's better.
The PTTs had an organization in Europe that they banded together. It was called the Commission of the European PTTs, or CEPT, and I always used to call them the Committee to Eliminate Progress in Telecommunications.
Oh, now is a good time to bring in Paul. Paul, how did Europe get involved?
Just one more statement about
Oh,
PTTs,
Erwin,
just so you get a
just
feeling
one more
for the
statement
state
for
of
Erwin.
communications at that time. One of the meetings we went into, and I won't mention the country.
Mention the country.
Before the lunch, they organized a very large conference. They brought in all the key people. I don't know, there must have been 40 or 50 key people. In front of everybody was you might call it a name tag, but it said 1.2.4, 3.5.7.8, no names, just kind of a coded scheme as to where they were in the organization. That was about it.
Hey, I thought it was an IP address.
It was Germany, clearly.
So the technical part that was the easy part. It was all these other issues to deal with. That was the fun part.
A good segue into Paul. Paul, tell me about Europe's role. I mean, why Norway?
Well, I would like to talk a little bit about what Erwin said about the attitude in Europe at that time, that they were going only for, say, the X25 virtual connection in a network, while DARPA would pursue the datagram, the datagram transmission. But if you see the situation, I mean, both alternatives have different advantages and disadvantages, of course. And what you see now, you try to combine those two concepts using multi-protocol label switching and the datagram. This blends very nicely together, but the X25 is, of course, completely out. Well,
Actually, Paul,
sorry.
at some point there was a lot of, many times the internet protocols have been challenged by something else, whether it was X25 or ATM or MPLS or whatever. It was going to replace TCP/IP. And the nice thing about the internet protocols is they run over everything, including you, if you're not paying attention.
Yeah.
So we were able to take every one of those protocols, including X25, and make it carry internet packets. So instead of having a competition, we simply made use of every technology that came along. So I have a question for Paul. The Norwegian Defense Research Establishment was in Kjeller, Norway.
Yeah.
But the satellite ground station was in Tanum, Sweden. Was there some complexity with trying to get all of the packets I mean, they had to go cross-country on a landline to get up to Kjeller from Tanum, I guess. Were there the same kinds of problems there that Bob and Erwin were describing for the other packet satellite connections?
Well, as you probably know, all the ARPANET equipment, the gateway, was residing in the building of Northside, So it was not on defense, within the defense property, and that was done by purpose in order to have people easy access to the equipment. Well, maybe Bob knows more about the discussions between the telecom administration and DARPA or NDRE for that sake about providing free of charge the uplink to the satellite, a decent line to from Kjeller to Tannum, the ground station owned by Sweden and Norway. And that was quite difficult and required lots of discussions in order to make that happen. And I think you had sort of the same in England, if I'm not quite sure.
Well, everyone had its own set of issues. In Norway, I mean, you say was it the Norsar facility? This was a Norwegian seismic array that DARPA had been working with the Norwegians on to monitor certain traffic near the Russian border. But as I recall, the Norsar building was, right across the street. I mean, I thought it was on the same property as NDRE, so it might have been easy access because it wasn't cordoned off by military, but it was right there, as I recall.
Well, the property itself, not the building, the property itself is owned by the defense.
So it was true.
Okay, so there was a little detail there. Yeah. But on the British side, let's see, what can I say? I think the hardest problem we ever had in getting the satellite imps into Britain was dealing with the MOD request that the US DoD indemnify the British Post Office in case anything went wrong, because here was this company, BB&N, that was building this equipment that we were going to put into a Goonhilly ground station, and the Post Office wanted indemnification, and since it was being done at the behest of the MOD in Britain, they wanted the MOD to indemnify them, and they would have no part of it because they were trying to facilitate it, so they passed the buck over to us and said, if we wanted this to happen, we had to indemnify them. Well, just try and make the argument in the DoD to indemnify another country for carriers' activity over there. It didn't work. In the final analysis, wiser heads prevailed, and we did proceed. But I wanted to ask Erwin, relative, we've heard about some of the issues on the packet radio side, and the ARPANET ones are legion, but you played a lead role in sort of helping to orchestrate the packet satellite net. What were some of the challenges that you faced that you think are worth noting for this audience?
Well, again, one, of course, was working with companies all around the world at the time, and that's when I really became hooked on email, because the ARPANET, and then as we began to get the packet satellite connections, et cetera, that was the way we communicated. So that was one thing I remember very clearly. But we were trying to deal with, on the technical side, with a satellite that is 22,300 miles, whatever it is, above the Earth, so there's long delays, limited bandwidth, and so you had to go ahead and design very carefully to be able to handle both very short packets, very long packets, in any kind of an efficient fashion. And we weren't designing it for a few ground stations. We really had the scaling issue in mind that you may end up with many, many satellites. So we had to come up with protocols that would handle that. And it's interesting. I was just looking back at the paper and looking at all of the technical issues we were dealing with and some of the solutions we had come up with at the time, which were fairly good. But we were really fighting a TDMA, time division multiple access battle. And so now looking back on it,
I'm not
and
talking
it came
about
up
the CDMA world. I'm talking about the satellite world.
No, it's TDMA up through the satellite, and in fact, just a few years later, it was actually working on a mobile satellite program for Hughes. That one day, coming back from a meeting after our second meeting together, where they had asked us to review a proposal they had made to the FCC, the technical aspects of it, was coming back from that, I suddenly realized that CDMA would solve a lot of those problems. So the CDMA we really got into in the cellular business actually started out as a satellite situation. But at the time of this experiment, we were very focused on TDMA, and of course there really wasn't the processing power available to really do a great job with spread spectrum and CDMA. It was a bit of a battle. And so we had to kind of fight out and work out a whole set of interesting protocols
Yeah, Vint, and then Don, and then Ginny.
So just a couple of observations about packet switching in general, especially in radio environments. One of the things that you want to do, because the transmissions are not continuous, is to very quickly acquire the channel and then accept the data, and then the channel shuts down and somebody else starts transmitting a packet from another source. So these are not only bursty channels that have to very quickly sync up, gather the data, and then shut down, but they're also dynamic in the sense that multiple parties are trying to get access to it in a way that doesn't collide too much, that doesn't create total congestion. And in the satellite world, it's especially tricky because of the long delay. You can't tell that you've interfered with anybody until the packet comes back down again. It's a quarter of a second up and down, which is a long time, even at the relatively low data rates that we're talking about, 64 and 128 kilobits a second. So my impression of both the packet radio and the packet satellite was that, I'm a software protocol guy, not a radio engineer, but my impression is engineering those things to quickly acquire the channel, get into sync, get the bits, and then shut down, and be ready for the next one was actually really hard. And it was hard in different ways, depending on whether it was the satellite channel or the ground radio channel.
That's exactly right.
Don, did you have something to add?
I just wanted to recall for you that actually packet radio had code division multiple access. There were surface acoustic wave devices. The trouble is we didn't have very many codes. But it was, I think, recognized. I think Bob asked me at one point to write some sort of paper about time division multiple access versus code division or whatever. And it turned out to be sort of a no-brainer in this really rough and tumble world of mobile digital radio, of course. And, of course, that turned out to be true for cellular as well.
Yeah, absolutely. I want to ask one question before we turn it over to the audience. And
Gina, can I just do a PS on that? When Don says that there weren't many codes, I think we had one, as I recall.
Yeah.
One code. We just had one.
I was gonna add that the later the code division multiple access came later in an upgraded packet radio. These first ones were just there was one code.
Well, I thought I said that, but maybe I didn't say it very well. Yeah, we had one surface acoustic wave device, so we had one code.
Yeah, I wanted to finally just ask Ginny, we're talking about challenges. You guys have challenges. You've got Ginny building gateways for all these.
The first gateways ever in the whole
first
world. Never been
gateways
built
ever,
before, and ever before.
She's right out of college. She's living in London, or then she moved in with Paul. There was working with his family. I mean, what were the challenges there? Because this must have been incredible. I mean, of all the challenges here, this gateway challenge seems to me to be one of the most impressive.
I mean, it was interesting that somebody characterized this as fun. I mean, it's
was it fun?
What 30 years will do for you.
Are you retired now, Ginny?
No, unfortunately. If
So
I had ever figured out how to make money on packets going through gateways, I would have been retired a long time ago.
Neither have they.
One of my recollections is, right before one of these demonstrations, we were working like crazy in one of the BBN labs, and back in those days, you were working in a cold computer room with the computers. And I think that Vint took us out to dinner, but what I actually remember was like at 2 in the morning, he's hanging over my shoulder going, are we going to get this? Are we going to get this? And so in some respects, working for DARPA hasn't changed a bit.
Same as it ever was.
If you look at the diagram, the picture that's here at the museum, and you see all of the individual pieces, and then you've heard what some of the challenges are for, in the packet radio net world, in the satellite net world, and all of those pieces had to be working in order for the experiment to work. And, I know there were days when we would look at all of the pieces and go, like, how are we going to get these to all work at once?
Did you think it would work? Did you ever look at this and say, no friggin' way? These guys are nuts.
She was much more refined than that.
I
never said that.
I never claimed refinement. That's Ginny's province.
Yeah. No, we got it to work, but I think that I'm not quite sure what's going on with the mics here.
Who's doing that?
Who's got control of the audio system?
There you go, Albert. Thank you, Albert.
Okay, thanks.
Were there any surprises?
I think the surprise is the internet of today.
Hello.
I think everybody here up at the panel here has to admit that the surprise is the internet of today. Back in those days, we were connecting networks at the rate of 2 networks every 6 months. And, nobody could really envision how big it was going to get. And that's why I think, in all honesty, if you ask people, like, well, what were you doing that day? And they were like, what? What day? Because, it was a continuous series of experiments. The only way I can date things is that I was installing gateways, for example, in Europe, and so I could go back to my passport. So that's why I know when I installed the gateway in London or why I installed the gateway in Norway. But, when did I do the one in Palo Alto? I didn't need a passport. So, we really didn't realize how momentous it was going to be. And I guess the message for today is, you don't know what all of you are working on that, 30 years from now, somebody's going to say, hey, remember that? There's always that potential there that you're making the next revolution right now.
It's interesting that we've heard a lot about, the issues of, getting the ARPANET, getting the satellite net, getting the radio net to all work. We haven't heard very much about the problems with getting the TCP/IP protocols and the gateways to work. And yet here we are some 30 years and running later, and the ARPANET is gone, decommissioned. The packet radio nets are all supplanted by much more modern and better technology. And the packet satellite net is certainly decommissioned, yet TCP/IP rolls on.
Yeah. Long live TCP/IP, I guess.
The biggest challenge we had was, as people explained, we were working with, in many cases, very low bandwidth. But the thing is, we were working also with very mismatched bandwidth. And so the gateways would sit like between a network that had like 9.6 kilobyte backbones and another network that had like 56 kilobytes. And then, so the gateway would always like fill up with packets from one end. And then the only thing that the gateway could do would be to drop packets. And every single gateway meeting, somebody would stand up and say, you're dropping packets? And it's like, they didn't have that much memory. Like, what else could you do with them?
Where would they go? And this diagram they're all referring to, do you guys know what they're talking about? It looks like a pile of spaghetti. And it's the most confusing diagram you'll ever see as they trace how these first messages
It's not the most confusing diagram you'll ever see.
It was the most confusing diagram I'd ever seen.
Just take off on a point that Bob made. The Internet is not just a bunch of protocols, but it's an architecture. And that's why when nets come and go, Internet persists, because it simply brings the other networks in and makes them work. But we were so determined to make sure that we had bulletproof protocols that BB&N, Bill Plummer, built a thing we called a flakeway. And the flakeway was a gateway that would drop packets, reproduce packets, inject them at random times into the network to cause confusion at the other end of the protocols.
A purposeful, confusing.
To be honest, we didn't need too much help from the flakeway. Other problems elsewhere. Some of the tests involved what we call Christmas tree packets. They had every possible, widget turned on, and John Postel, rest his soul, used to have these bake-offs where you'd get first crash awards by knocking down somebody else's TCP implementation with a Christmas tree packet. Anyhow,
yeah.
It was the persistence of and determination of people to make this as bulletproof as possible, which I think has allowed the protocols and the Internet to survive as long as it has.
Thank you, Vint. Are you guys ready for some questions? You've been awfully silent. There's one in the back. Thank you.
Can we get roving microphones here?
Yeah.
And that would make it a lot easier.
He begins with what he's really amazed at. So.
Yeah, if you could identify yourself, that would
and if you could identify
be good.
yourself quick. 2 roaming mics, one on this side, one on that side. I guess they're not roaming,
people might
they're
want to
standing mics.
queue up ahead here. Could you introduce yourself too, by the way, once you can figure out how to get the microphone turned on?
Yeah, pop that one up. Or you could shout really loud.
No?
No?
How many engineers does it take to turn on a microphone?
How many audio? No. Albert's a good guy. All of our mics work. That's an amazing thing, 7 mics on a thing.
Is it on?
It's on.
Well, why don't we...
Tell us who you are, sir.
Yes, I'm Alan Weisberger, volunteer for the Computer History Museum and also representing the IEEE Communications Society. Actually, Vint Cerf had an ANSI X37 meeting where the debate at that time was X25 versus IP. It was December of 1978 in D.C. But here's my question.
Wow. You don't look that old.
I am.
That's incredible.
What I'm still astounded by is how in the mid-1980s, the government and IBM and many other companies were advocating OSI, in particular ISO Connectionless Network Protocol and ISO Transport Protocol. How did TCP/IP triumph over OSI, particularly in Layer 3, Layer 4?
All right, we'll just try to keep answers short so we can get a lot of audiences. Bob, Vint, one of you guys, pick it.
I'm sorry.
Someone answer this question.
Actually, the X25 stuff, if you will remember, was Larry Roberts' contribution, along with others who somehow thought virtual circuits were easier to sell than this datagram stuff, because they couldn't explain what it was you were buying when you bought a datagram network. So they went down the virtual circuit path, but that didn't stop us from running TCP/IP over X25, which we did with the CSNet in 1980, and we did it again with the NSFNet, portions of the NSFNet in 1986. So I think the idea that the architecture will run on top of virtually everything was fundamental to the design. The OSI clash was a different kettle of fish. In 1978, the first architecture documents for OSI were published. Some of them by authors were friends of mine from other earlier days. But the problem is that whole effort generated an awful lot of documentation, but not very much implementation. And so people were forced, in some sense, even when they were supposed to be buying OSI, to buy or at least acquire TCP/IP, because it was the only thing that was available that worked. And as you
sort of like Windows.
Sorry? Yeah, right.
Like Vista, yeah. I'm stuck with that thing. So I'm sorry, Microsoft, if you're here.
There's an old expression, things that work persist, and indeed they do. Well, we have quite a lineup here, so maybe we should switch back and forth between microphones.
Yeah,
in which case it's Danny Cohen.
Switch back and forth. Go ahead, sir. Identify yourself.
Hi, my name is Danny Cohen. I was at USC ISI at the time.
There you go.
Thank you. I want to tell something that happened 5 years later, in 1982. Yeah, we knew about the packet radio that was done at SRI, but we were not officially part of this program. And then we heard that they were paid to do an airborne demonstration. And we thought this was really neat. It was too much fun for us to miss just because we did not have funding. So we decided to demonstrate our own. We had 2 radio hams and a pilot at ISI, so that was practically all we needed. So we built some equipment that cost about $600, and which was sort of a modem connecting packet radio with packets. Yeah. And we invited Bob Kahn, and we took him in a plane over Los Angeles, and we flew around. As we were flying, we were connected from the plane to ISI over the ham radio link. And from there, we were through the ARPANET to Vint, who was at home in Virginia. And Bob and Vint were discussing some important things over the connection for about half an hour, and then we landed. Bob looked at everything and asked, how much did it cost?
Wow.
And we said $600.
$600?
And
you guys have done that?
He looked at it and he said something which I interpreted as a plea not to tell anyone about it.
Don't tell anyone about it.
A promise that I kept until this very moment. Sorry, Bob.
Is it true, Bob?
Let me give you the other side of the story.
Oh, just yes or no. Is it true?
The actual demonstration that they put on was a very effective one, and Danny was one of the key players in that. They used regular radios that you get off the shelf, just sort of strap them together. The problem that we had was that, first of all, we had one major program in packet radio already going. In DARPA, it would have been impossible to get a second one going. Just wasn't the way things worked. Second of all, the way the original program was couched, it was supposed to deal with some of the specific military issues, which is why some of the spread spectrum issues were, put forth and the like. And the ability to sort of switch on a dime and go fund another project for lower cost was just a total non-starter at DARPA. So despite the fact that I thought it was really good work and really nice, there was just no way that we could literally inject that into the mix at DARPA. And we had seen that before. I don't know how many times people had come to me to say, why don't we start a program to build the imp on a chip? These ARPANET imps were mini computer-sized devices. The original ones cost $100,000. After lots of work, BB&N got them down to $25,000, and the idea that you could put it on a chip sort of implied that maybe it might cost $1 or nothing.
Would that have been called a chimp?
Or a GIMP.
You might have called it that, Vint. I don't know that I would. But I think it was more like a chump, because the bottom line was the costs of running the network were not in the costs of buying the equipment. It was in the buying of the lines and paying the service charges. It was in the annual maintenance. So even if we got the cost of the imps down to nothing, it wouldn't have made a material effect to DARPA on actually running the net. And the same thing was probably the case there. So despite the fact that Danny and his friends had done a good demonstration, there was just no way we could inject that programmatically into DARPA.
Thank you for the question.
We were right. It was lots of fun.
It was a lot of fun. Well, that's what it's a lot of fun for everybody but Ginny. Well, in retrospect, it was a lot of fun. Question over here.
Hi, Brad Templeton.
Hi.
My first question, what was the ping time? The second question, the real question, is that a lot of people felt one of the most enduring results of this work was connecting people in different countries. So when did you bring it up full time across international borders so that there was a regular thing and people could have FTP sites and email between the countries?
Who wants to take it?
Yeah, I'll address that. I mean, the extension, remember, this all started with DARPA funding. And normally DARPA puts its focus on domestic kinds of things. We made the pitch early on that having international participation was really a very important part of the program. We had to clear it. There's a whole process that you go through. You just don't arbitrarily decide to give a contract to Norway or England. You've got to make the justification, get the approvals and the like.
But why? Why, Bob? Why? I mean, the ARPANET was originally a U.S. system. Why did you think an international? Why did it matter?
Oh, well, wait, can I respond to that? Can we get... The thing is, that it wasn't just the ARPANET. It was the fact that we were trying to use this system for resource sharing, and the resource sharing aspect of it was emphasized by Larry Roberts and others. The research departments that were funded by ARPA wanted to be able to use each other's computers. But when you start getting into computers and command and control, the first thing you recognize is that the military is going to have to work with other countries' militaries.
That's what I thought.
And so commonality is really important.
Bob, I interrupted you.
So we wanted also to sort of have international participation, because even at the technical level, we understood that if we were successful, other countries might be as well. They probably would do similar things, and that interconnectivity was going to be useful in the long term, and so having some representation in that would be useful. The U.S. had already been funding the folks in Norway to work with us on seismic arrays. They had arrays all around the globe, a number of places, and so they were already in the international domain. I remember a trip that they sent me on to Korea to explore bringing back data from the DMZ. And I went on a helicopter trip looking for this seismic monitoring station on the DMZ. It was all wooded up there. And the guy who was driving the helicopter, I was kind of nervous because I couldn't tell where the line was.
And there's no door.
There was no, it wasn't like the 50-yard line in a football game.
Yeah.
And so he said, look, the pilot said, look, I do this, dozens of times a week. He says, I have no problem. I know exactly where it is. Don't worry. And we get up there, and I notice he's circling, and we must have been up there for 5 or 10 minutes, and I finally said to him, I think we're circling. He says, for some reason, I can't seem to find it. And I'm thinking, maybe we're over the DMZ and about to get shot down. But the bottom line was there was a need for international cooperation and collaboration. We had 2 very good partners initially in the folks in Norway and England. and that was pretty much what it was limited to initially. It later grew with the satellite system into Germany and Italy, and eventually, there was much interest on other parties in getting part of the Europeans had mandated that only X25 would be used in Europe.
The Europeans are interesting. The Germans are still using OS2, the whole country.
So they had mandated
Nobody thinks
X25, and that basically looked to a lot of people in the PTTs that would preclude the internet from getting over there. Well, along came Cisco with a router that had X25 on one side and Ethernet on the other, and so they could sort of, port over it. And it was when that happened and NSF got into the networking business big time that the international stuff really opened up to a much larger extent than it was initially.
Actually, there's a small anecdote that's worth recounting. The person who made the decision that the NSFnet would use TCP/IP was from Ireland. His name is Dennis Jennings. And Dennis was a visiting scientist at NSF running the supercomputer program, and they were going to use the NSFnet to connect the supercomputers together. And he made the decision to use TCP/IP, even though it was actually considered a terrible mistake because he should have used OSI, according to some of the other government participants. But when Bob and I started working on this thing, we knew we shouldn't patent it because we didn't want to build any barriers for people to adopt its use. And we didn't make it secret. We didn't prohibit the publication of all the details because the only way that we had any possibility of making this an international standard was to keep it as wide open as possible. And
Wow.
I think if we hadn't done that.
Fantastic. Did that answer your question?
Well, I was still curious as to what year the demonstration became production and other countries were online.
What year the demonstration became?
Went into production, real use, and the countries.
I'm not sure what you're asking at what time the internet became.
No, he means the experiment, the 1970s.
Well, no, this experiment was temporary, right? You
experiment was an experiment. It happened at a given time.
It was just an isolated thing. Yeah.
So when did it become real?
Well, all of the pieces were in place. I mean, there was the satellite net. It was up, connected with gateways back into the U.S. Just nobody had ever tried to do an experiment with it in this form. I mean, if you wanted to communicate between, let's say BB&N and UCL, it probably went over the satellite net anyway.
Do you mean
the packet radio was not an installed system. It was a test kind of. Don can probably talk to this better than I can, but I mean they had to roll out the van. I mean they had some radios up in the hills, but it wasn't like you had 1 million people in the Bay Area with cell phones in their pockets.
Mm-hmm.
I mean there were just a handful of these radios, and you had to sort of roll them out and decide to do something with it at that point in time.
It's always amazing to me the amount of payoff one gets from a fairly low investment. And clearly the ARPANET into the Internet was one of the greatest payoffs ever. But even with the satellite network, I think it was only couple of years later that we got into VSATs, very small aperture Earth terminals. So suddenly Walmart was connecting all its stores up with small terminals. All the gas stations were connecting. So these things very quickly propagate, not necessarily in the experimental exact stage, but very quickly into commercial capabilities.
Well, Paul was telling me that, we sort of lose sight as to what some of this was for, and some of it was for resource sharing, and literally that, researchers on one part of the network didn't necessarily have access to the big computers. So Paul was in Norway and had access to computers you were using here in California. And when was that happening on a regular basis, Paul?
Well, when I came on board in end of '74, we didn't have any facilities at the Norwegian Defence Research Establishment, but we had the ARPA tip or node. The NORSAR tip was installed in June of 1973, and when I started to work on this in end of '74, I had the terminal in my office connected to the tip, and then I could read my mail at ISI because we didn't have any host computer. And then I later started to do some speech experiment using the PDP 1140, the same machine as Ginny was programming as a gateway, but then used as a speech host. And that machine didn't have any peripherals. It's just a box.
Yeah.
And I could reach that box through the ARPANET, through a program at ISI. I could modify the program, link and assembly and link it, and then download it into the gateway next door to my office, and then debug it. And I think this is an example of the resource sharing. I mean, computers were expensive, programs were expensive, and lines were expensive, and they had to be shared by as many users as possible.
Don?
Can I add one footnote to this to show you? I think it was a fairly sophisticated world for its time. When we put a packet radio on Mission Ridge or Grizzly Peak or someplace that was really remote here, and it was wintertime and you couldn't get up, it was obvious that you wanted to be able to do remote debugging and reloading. So across, even though we didn't think about it maybe as only a labor-saving device, but we were doing this cross-net. In other words, you could go cross networks and fix a repeater on a mountaintop someplace else, either debugging or reloading or whatever. And I think that was a fairly sophisticated thing for the time. I just didn't want to let this is not what hath God wrought. We're sending back and forth. There was a lot of development here that I think had lasting impact on networking and the way those networks are maintained.
Yeah, so it sounds like the answer is the experiment wasn't intended to be a long-lasting satellite packet radio ARPANET thing. It was an experiment to show internetworking and to solve the internet problem. Did I correctly answer that? Good. Next question.
I'm Abhay Bhushan, and I was there in the first network working group with Vint Cerf and Bob Kahn, and all those people connected the MIT node and wrote the FTP. And just a bit of history, email was first part of FTP for the first few years. And then Ray Tomlinson, is he here in the audience?
Who?
Ray Tomlinson developed the @ sign for Bol-Beranek and Newman between the 10Xs, and I put that into the protocol, so the @ sign separates the user with the host.
That's interesting.
And now question, okay? Question is, when you did this experiment in 1977, 30 years ago, what applications did you use? Was it just transmission at the TCP IP level, or did you send emails or transfer files as a part of this experiment? What is the nature of the experiment?
Yeah, what were in these packets?
Okay, so Don probably has the more definitive answer, but think about what we had out in the van. There was a terminal interface unit. So basically you had a terminal that was interacting with something at the other end. The something at the other end was a KA1010X at USC ISI. So most likely this was a purely interactive terminal to host kind of exchange. But Don, do you have better detail than that, or is basically what it was?
I think that's a fair statement. We had things like traffic sources and other things that we used to test the networks, but this particular event, I think, was really essentially a login cross-net to a host, which as a server would be today.
So like a telnet protocol, just log into a distant server
It's
using telnet.
Yeah, there was a process. I don't think any of us remember what the process was.
Well, it's telnet. Telnet was the one to use the login.
Actually, I think Dan Lynch, I saw him downstairs. I don't know if Dan is up here.
Dan's
he
here.
probably remembers.
He's
Wasn't
back
it a KL10 back then, Dan?
No, he was at SRI.
Oh, at that time? Okay. In 77. In 77?
Wow.
That Dan, did you didn't introduce yourself. Dan Lynch ran the computer systems at USC ISI during the time that this experiment was being done. Weren't you there? Oh, so you were on the other side that you didn't. When did you move to ISI? Oh, wrong number.
We'll have to get you guys
Got it.
together after the little cocktails after the.
You guys got to catch up.
Nice to meet you, Dick.
Okay.
We're running out of time, so let's have it.
I'll be kind of
Didn't we already have you before?
No.
Okay, sorry. I don't have my glasses on. This is a problem. All right, go ahead.
I'm Vic Wheatman with Gardner, and Vince, I have one of those infamous T-shirts that you wore when you were the centerfold of Boardwatch magazine.
That was me.
No, him, Vince.
Oh, good. I'm sorry. Whoa, I never did that. It scared me to death right then.
You're not going to tell about the T-shirt. Oh, well, all right.
No,
that T-shirt said "IP on everything," and
My my question is, and I think there's a quick answer, given it was experimental, given who was investing in this or supporting this, given there was for communications among military apparatus, was there ever any consideration, I know the experiment probably not, but around that time, was there ever an aha moment when someone said, is this thing secure?
I was wondering the same thing. An excellent question. Was this thing secure?
Oh, well,
did the
actually,
military or anybody wonder?
No, we knew it wasn't, and so there's an irony here. The way I remember this, I was at Stanford University, deep into the design of TCP/IP with a bunch of students, graduate students, and I realized that in order to secure this from the military point of view, that none of us had the expertise we would need to do that. So I went to the National Security Agency. First visits were about 1975, before I got to ARPA, and there began a parallel program of development of a fully secured internet using, crypto grade, government quality crypto grade stuff, and that design used packet encryption technology, which had to be invented in order to be used. And I couldn't tell anyone about it that was in the rest of the internet community because it was all classified. So there was a sort of irony associated with watching all the problems that have arisen even today, knowing that the technology was there but it wasn't available. And Marty Hellman, who's somewhere in the audience, there he is over there, along with Whit Diffie, published the first papers on public key cryptography in the 76, 77 time frame. So I knew about that, but RSA hadn't been invented yet. Just this concept paper had been put out. It broke through some really great conceptual barriers. Public key cryptography wasn't available to us either until, of course, now much later. So in many respects, looking back, I wish that we could have incorporated into the design some of the ideas which are now much more easily implemented, but at the time it just wasn't available to us.
Well, I would add to that despite what you were doing, Vint, DARPA had a program with the folks at the fort to demonstrate that you could do end-to-end packet encryption. And we actually got their approval to take one of their encryption devices and put processors on both sides, so you could take the unencrypted side, feed it through the encryption device, and then feed it out the other side into the net. And BBN actually built those devices. They were called private line interfaces, or PLIs. And the very first versions that came out, you couldn't change the address that would get put on the packet, so it would literally only send it to one place. And after a short while, the folks there got the idea that maybe it was okay to allow 5 wires to bypass it if it didn't change their signals too quickly, and now you could address up to 32 different things. Yeah. And those were actually widely used for certain military purposes on the internet long before any of the more detailed investigations took place in parallel.
Great answer. We have a few more minutes left, but I'm determined to get all your questions. So maybe you can pound the questions out and you can pound out the answers. Let's try.
We'll do it quickly. I'm Chris Primesberger. I write for eWeek.
Hi, Chris.
Hi.
I used to work
just
there.
a general question for anybody who wants to jump in. What were the, from between 1977 and when the internet was really starting to be used in the mid-90s, a lot of years went by. What were the key, maybe 2 or 3 key traction points that you see, that you saw the internet starting, as the internet started to gain critical mass? What were the key points that?
First of all, it didn't really have any critical mass at all until 1983. So 77 was 6 years before we rolled the internet out. And in my view of traction is 2 parts. First one is the rollout in 1983, where we demanded that everyone using the ARPA-based networks, not ARPANET, but all of the networks, satellite net and radio net, had to use TCP/IP as of January 1, 1983. Not everyone made it quite on time, but it was a major change. Of course, there were only 400 computers involved at the time. The next big kick, in my view anyway, comes around 1989, when the first commercial internet services become available from 3 different internet service providers in the United States. Not long after that, the first implementations of the Netscape Communications web browser and service machines start to pop up. And so somewhere in 1992 to 94, I started to see serious uptake of internet. People would come and apologize for not having an email address on their business cards. people began to realize that they could do something with this World Wide Web that they couldn't do before. But it has taken quite a long time from the conception to this test to the 1983 rollout and later to see the Internet really take off. But since '88, it had been doubling every single year for quite a while.
One of the things that took place during the late 70s and entirely through the 80s and part of the 90s as well was the development of the Internet standards process. I mean, the social processes that went along with the Internet so that it could evolve and that you could get, all these companies around the world and users to somehow be able to take this thing and evolve it when no single party was in charge of everything was really a serious challenge for us. And Vint and I did a lot of that work when we were at DARPA, and we continued a lot of it from CNRI. In fact, I think we just got out of the standards, running the standards part of the process through the IETF in 2005, and ICANN, of course, was spun out of ISI and continues to this day. So that whole part of it was really a serious part. We had one session, I remember Vint and I were asked to talk about the Internet. That was Mark Bisno, I think, and he had an hour set up. It was, I think, a television setup or radio setup. I don't remember the details, but he spent an hour, and we went over going back from day one. At the end of the hour, he said, "Hey, that was great. I think we're done." And Vint and I looked at each other, and we said to Mark, "Well, that was fine, but we never got to talk about the Internet. It was all about ARPANET."
Yeah.
So
It might happen tonight.
So he said, "That was great." He says, let me call my producers in New York. Maybe we can have another hour." So he calls them, and they say, "Fine." And he said, "All right, so we got another hour here." So in 1992 or 3, the web shows up, and we spend the next hour talking about the web. At the end of which, and sort of where the Internet's going, at the end of which time he says, "That was great. Now, did we get it?" And we said, "No, we still haven't talked about the Internet." So most of what happened about the Internet happened in that period between 1973 and roughly early 1990s.
Question here.
I'm Les Ernest. This is not so much a question as a nitpick. Your presentations here began with ARPANET, which was indeed the first, I would say, general-purpose computer communication system. But, in fact, it was not the first computer communication system. That was SAGE, which interconnected 20-some computers in the U.S. and one in Canada.
And also Autodin in the DoD, Autodin 1.
Yeah. And it included all the same kind of hardware that ARPANET did. That is, well, one of the guys there invented the modem. It had packetized radio of sorts going to aircraft. And as a matter of fact, Collins Radio was involved in that. And I recall that one minor blunder was that they carefully laid out the packet structure, but neglected to define whether you send the high order bit first or the low order bit first. And indeed, a different contractor built the ground station, and they did it backwards, so that had to get fixed. But anyway,
and so went SAGE.
The point I'm trying to make is that SAGE was in fact the inspiration for what turned out to be ARPANET. Licklider had worked on SAGE. Somebody had mentioned that he was one of the inspirers of ARPANET, and he got that idea, I'm pretty sure, from his work on SAGE. So that's.
Can I get nods of approval because we have 2 minutes? Yes, agreed.
Could I just say one thing about SAGE? There's a piece of it here in the museum, and it was the first computer I was ever introduced to in 1958, and it sparked my personal interest in computing.
So you got agreement. Question.
Alec Dare Abrams, Sony Electronics, and I was just a Dewey-faced graduate student at the time, happy to get a FTP file over in a couple tries before Lempel-Ziv. And the first short question is that air conditioning unit really vintage 1977 that's on top of that van? The other question is, the easier question is maybe for Vint and Ginny, the kind of programming in the brand of distributed programming that's done in address resolution, that sort of stuff, demands a particular, maybe sort of a programmatic schizophrenia to do, and it's a very special case, but can you trace any influence that the success of that kind of programming has had on distributed computing following that?
Yeah, briefly, please. I've got evil eyes in the back.
I don't have a good answer.
Really evil eyes.
Anybody else? No? Don't have a good answer, I'm afraid.
No answer?
I don't have one.
Anyone else? Don, you always have an answer. Bob? Ginny?
He's talking about sort of basically prototyping things?
Yeah, prototyping.
I mean, yeah, I mean, that's what we were doing. I mean, that's why we had, small-scale experiments and one piece at a time and, slowly building things up to where we are today.
All right, there you go.
Peter Neumann, SRI. I have a short question, but I need to motivate it. I remember being in Bob's office with Vint, 70s, 77 maybe even, and I raised the question about the lack of security and I remember the answer was pretty much the same, we're going to let NSA do that. The question really, I just come from the Pentagon, talked to Colonel Russell, who said, I said, you have a really serious security problem. He says, there is no recognized security problem in the Air Force. I said, you're out of your mind. He said, no, if there were a problem, if I could admit there were a problem, I'd have to do something about it. There's nothing I can do about it. The question for you guys is, if you were to start over now and plan for IP version 8 or something out there, what would you do to resolve all of the problems that are still confronting us that we've had around? Tom Van Vleck is here, part of Multics with me back in the 60s. Where we solved a lot of these problems in the system sense, but not in the networking sense. What would you do if you really had your druthers and you could do it from scratch, or you could incrementally evolve what you have now?
Excellent question.
I do two things myself. I would add put 128 bits of address space in, so we don't have to go through this V4 to V6 agonizing conversion. And second, I'd put in end-to-end integrity and authentication, so that we could find out who the hell we're talking to on the other end.
Anyone else want to add to that? That's a great question. No? Don?
Well, I would only add that much of the debate about security was the tension between the needs of the private sector and needs of law enforcement and national security. And that's a policy issue that isn't one that the technical community can really solve by itself. It's got to be part of a whole systematic approach that that comes to grip with what's acceptable and what's not. Had we opted to really delve into the security issue up front, we never would have created the Internet.
Thanks,
never would have happened.
Oh, go ahead, Don.
I think I just want to clear up something. People shouldn't think that this technology is inimical to security, although it presents difficult problems. But the MILNet went its way, and it has a packet switch world that's secure to this day. It's at least secure in most ways we define that. So it's not necessarily the technology. I think in many cases the horse was out of the barn, and there was a demand for this kind of thing that just outpaced the difficulty that throwing security over it would have, it created a real damper, I think, on the innovation that was coming.
Thank you.
That's too bad.
The kind of some of the bureaucratic problems you can run into. I remember when we were first trying to get the standards for CDMA and then be able to export it, and NSA got into it, and for a while it looked as if it would be not usable because it had the word code division in it, and that immediately got everybody worried.
Very funny. May I take two more questions, Mark Weber? Audience, is it cool with you? All right, let's go.
My name's Jim Mauer. Got a real quick one then.
Hi, Jim.
So what was the ping time from the van to the KA-10?
Good question. The round trip time? It had to have been at least 2 seconds, I would guess.
2 seconds? And back? Yeah? Okay. Good question.
Oh, the response.
What was the round trip time?
Yeah, the round trip time.
Well,
round trip time.
You want to know for this particular demonstration?
Yeah.
I'm sure we recorded that, but not in our memory.
It might be.
My guess it's milliseconds.
No.
It's.
No. Wait a minute.
It was seconds.
This had to be in seconds.
Again, when we use it.
Norway,
those
London,
were ARPANET.
Van.
That's right. Those were ARPANET delays, and the delay of the satellite, I guess, was a second or so, wasn't it? But actually, I think I mentioned earlier that you went through all these networks and all you saw was delay. I don't actually remember us measuring the delay on a round-trip pinging basis. In fact, opening that connection to a host, I'm not sure we would have measured it anyway. It takes a special packet generation to do that, and a special reflector at the other end where you're collecting timestamps as you go through the network. I'm not
Ginny,
sure
you
we
have a
did
rough
that.
guess?
That was all being done, though.
Yeah, I mean,
Well,
Ginny, you're...
As I recall, we were thrilled when it worked.
Yeah, he's happy it worked.
Can't answer it.
Can't answer it, sorry. Question. The final question, agreed?
Jake,
All right, the final question.
Jake, wait a minute. I make sure everybody understands. Jake finally ran the Network Information Center for SRI and for the ARPANET.
Didn't recognize you, Jake.
So this is where all the domain names got recorded and all the other stuff that happened. So bless your heart, Jake. What's your question?
Well, I have two short questions that I think only this group of people could answer. One was, it was rumored, or it was part of the network folklore, that one of the repeaters was in Grace Cathedral. Was that ever true, or was it just folklore? And the second one is, I had the pleasure of having John Postel in the office next to me when they were doing some of the bake-offs. And I remember that he was very upset because people weren't getting their work done and turning in their results. And he was really pounding on everybody, get it done, we needed to have it done. And so this one day, everybody was supposed to have it or else. And he came running in the office, and he was just cracking up. And I said, what's going on? And he said, well, that gives new meaning to the word bake-off, because the one guy that hadn't reported in had a fire at his house. And what I'm trying to find out is who was that person. I've never been able to find out who that person was.
Who had the fire, and where's the repeater in Grace Cathedral?
I have no idea.
No one knows?
Mm-hmm.
Will you guys make a commitment to
Shall
try to
we name
find
the
out and
mystery?
email her?
Well, if anybody knows the answer to
Somebody
this,
knows?
I'd like to know.
You get he will tell you the Grace Cathedral story privately. It must be good. E-Week reporter, hang out for that one. I want to thank you guys for being one fantastic audience tonight. And
Gina?
I want to thank Vint Cerf. I want to thank Jim Garrett. I want to thank Erwin Jacobs, Bob Kahn. You guys sure know how to talk and lead a great panel. Don Nielson, Paul Spilling, thank you so much for coming all the way out here. And Ginny Travers for all that work she did on the gateways. It's amazing. Thank you for coming, you guys. And Don wants to say something.
I think this is worth sitting here. First, maybe you do mind. First of all, I wanted, fixing the van up was tough, and there was a couple of people that really helped a lot. Don Alves and Dave Beyer, who were here, and Mike Frankel and some others participated. It was not an easy job, and I wanted to thank them. Also, Jim Mathis, who probably should be sitting here in my stead. Wanted very much to be here, and it was sort of an 8-hour brain operation that kept him away. Finally, we have some sponsors, and also I thought those who have a packet radio orientation might like to see a small video. First of all, with respect to packet radios, Collins is still in the business and manufacturing them, and Mike Cisco is in that organization if people would like to know what the current situation looks like in packet radio technology. Just talk to Mike. Are we ready to run a video at 3 minutes? What it is up in the state of Idaho in a National Guard test range. This is essentially a Wi-Fi version of packet radio. Mark, I don't know whether did you bring a little? Okay. There's a little device about the size of a pack of playing cards that represents the packet radio terminal interface unit for this particular exercise. And if you could run it for a second, we'll see the nodes come and go. And this was in the spirit of packet radio way back when, and now it's done with something that you can lose in your pocket. So hang on. The red node is the mobile node, and you watch the links being This is real stuff, real time, and current, so Mark Lewis worked hard to be able to view this thing, but
Nodes aren't moving?
no, the blue nodes are not moving, just the red one is. But every time you use a Wi-Fi connection or something, there's something like this going on in the world where the connections are breaking and being made and remade, and that's the kind of the wonder of the digital error-free world, that all this kind of dynamics can take place. And I think it's one of the legacies of this whole thing we're celebrating today, is that stuff is now common and buried beneath most of our visibilities. So, and the last thing I wanted to say is that without DARPA, lights please, this couldn't have happened without an organization like DARPA. That's it.
I think that's it, folks.
you.
Show's over.
Thank you. What a pleasure. Yeah, thank you. It was tough stuff.
Sounds like she's not going to.